Hello to my lovely viewers. Welcome again to Mathematics and I still remain your presenter, Jeff Nino. And in our last class, we discussed about indices. So today we are going to be looking at how we can apply the laws that we treated in our last class in solving some problems. All right, we have 8 questions on the board, as you can see, and then we are going to be solving them one after the other. So let us begin. So the first question for today says 12y raised to the power of minus 5 over 3y raised to the power of minus 2. Now how do you simplify this type of question? Now it is very simple. You will notice that we have 12, we have 3, we have y, we have y. Now the 12 divided 3. Now 12 divided by 3 gives us 4. Now you will notice that my base here is y and my base here is y. And the sign separating them is a division sign. Remember the second law we talked about yesterday, the division law, that says when you have x raised to the power y divided by x raised to the power z, you pick one of the x and then you subtract the powers. So that is exactly what we are going to do now. We pick one of the base, which is y, this is my y, and then I subtract the powers. And the first power I have is minus 5 minus, the second power I have is minus 2. Now this becomes in the brackets. The first power minus 5 minus 2. Now remember, how did I get this minus? From the division sign. Now you will notice that I have two negative signs, minus minus. So when you multiply, minus times minus gives us plus. So here it becomes 4y raised to the power of minus 5 plus 2. Now students find it difficult in solving problems that have to do with negative signs. Now if you have minus 10 plus 2, what does it mean? Now naturally, when you see the word minus, in a very simplified way, minus means you are owing. Let us take it like you are owing, and then plus means you have. Now here simply means you are owing 10 naira, or you are owing number 10, and then you have 2. Now when you pay the 2 that you have from the 10 naira you are owing, you will see you are still left with 8 naira. Now what sign shows that you are still owing is the negative sign. So it means minus 10 plus 2 gives us minus 8. So it means that in this case now, you are owing 5 and then you have 2, because plus means you have. Now when you pay the 2 that you have, you will still be owing 3. Now what sign shows that you are still owing? It is the minus sign. So automatically what do we have? 4y raised to the power of minus 3. Now you will see that this y raised to the power minus 3 alone is a law that we treated yesterday under negative power law, which I say if you have x raised to the power minus y, something like this, we remember the negative sign becomes 1 over, and then the x and your positive y comes down. So what am I going to do here now? In order for me to remove this negative sign, I bring it down. Now when I bring it down, it becomes 4, because when this one comes down, it will remain 4 on the numerator. So it becomes 4 over, then here becomes y raised to the power of 3. Because once it comes down, when a negative power comes down, it becomes a positive power. Are you getting it? For example, if you have 4a raised to the power minus 2. Now this your a is carrying a negative power 2. But when I bring it down to the denominator, it becomes a positive power. It becomes 4 over a, then the minus is out, raised to the power of 2. That is it. Now it means that when we solve this question, the answer that we get is 4 over y raised to the power of 3. Now that is question number 1. Now question number 2 says 81 over 16 raised to the power of 3 over 4. Now we also treated a law like this, and I said this law is called fractional power law. And it takes this format, x raised to the power of m over n. And I remember telling you that the denominator becomes the root of the base. So here becomes the nth root of the base raised to the power of the numerator n. So exactly what we do, we will apply this law now in solving question number 2. Now let's see how it goes. Now, automatically my denominator is 4. So it becomes the 4th root of the base. Now you will notice that the base is a fraction, but that doesn't matter at all. So here becomes the 4th root of 81 over 16. Yeah. Raised to the power of the numerator is 3. It's as simple as that. Now I also remember telling you guys in the last class that if you have something like this, what does it mean? Remember, this 4th root is affecting the numerator and it is also affecting the denominator. So when you say 4th root of 81, what does it mean? A number you will multiply 4 times, you will multiply itself 4 times to get 81. And I think that number is 3. 3 times 3 is 9. 9 times 3 is 27, and 27 times 3 is 81. So what does that mean? It means the 4th root of 81 is 3. So here it becomes 3 over. Now, what's the 4th root of 16? Again, what will you multiply 4 times to get 16? I believe that is 2. 2 times 2 is 4. 4 times 2 is 8, and 8 times 2 is 16. So it means the 4th root of 16 is 2. So here becomes 2 raised to the power. What is my numerator? My power now becomes what? 3. Now also we said, when the power is outside, it affects everything inside, be it a fraction or a whole number. So automatically, here becomes 3 raised to the power of 3 over 2 raised to the power of 3. And you know what that means? 3 raised to the power of 3 simply means 3 times 3 times 3 into 3 places. And 2 raised to the power of 3 means 2 times 2 times 2 into 3 places. And automatically, what do we have? 3 times 3 gives us 9. 9 times 3 gives us 27. So here becomes 27 over 2 times 2 gives us 4. And 4 times 2 gives us 8. 27 over 8. So this becomes the answer when we solve question number 2. Okay, without wasting time, we're not going to touch it. We'll be using this part so that we can see the question to the end. So let us go to question number 3. Question number 3. Now, question number 3 says 4x y raised to the power of 2 all raised to the power of 2 over, we have 2x all raised to the power of 3. Now, how can we solve a problem like this? Now, you notice that we also treated the law in our last class that I called the product power law, when the powers inside is being multiplied by the power outside. Now, you will notice something. 4 is carrying power 1 because it is standing alone. X is carrying power 1 because it is standing alone. But Y is carrying power 2. Now, what does that mean? It means the power outside will times each of these powers here. So now, here it comes. Let me break it down so you get it completely. Now, it becomes 4 raised to the power, I'm coming. It becomes 4 raised to the power of 1, the 1 here, times the power outside, times 2. Are you there? Then x raised to the power 1 times the 2 outside, and y raised to the power 2 times the 2 outside. You see, the power outside multiplied everything inside. So all over, the same thing applies at the denominator. This becomes 2 raised to power 1 times the 3 outside, then x raised to power 1 times the 3 outside. How did I get the 1? When you have a number like this, standing alone, what power is it carrying? Power 1. Are you with me? So without wasting time, let us proceed. 1 times 2 gives us 2. So here becomes 4 raised to power 2. 1 times 2 gives us 2. S raised to power 2. 2 times 2 gives us 4. Y raised to power 4. All over. 1 times 3 gives us 3. 2 raised to power 3. 1 times 3 gives us 3. X raised to power 3. Now, let us see. 4 raised to power 2 means 4 times 4. And that is 16. So automatically, here becomes 16x raised to power 2. Y raised to power 4 over 2 raised to power 3 means 2 times 2 times 2. And that is 8. So here becomes 8x raised to the power of 3. Now we are back to the beginning. 16 and 8 can divide each other. So 16 divided by 8 is 2. This is 2. Now, I have base x I have base x. What do? Pick one of the base x. Then because it is a division sign, what do I do to the powers? I subtract. So what is the first power of the numerator? 2 minus, what is the power of the denominator? 3. Pick one base. Now also, you will now see that I have just one y. There is no y at the denominator. So I will still bring it down and say y raised to the power of 4. Now, 2 minus 3 gives us minus 1. Because when you have, there is no way you can subtract a bigger number from a smaller number. For instance, naturally, 10 minus 4 gives us 6. But 4 minus 10 will give us what? Negative 6. Because why? You can't take a bigger number from a smaller number. So the result gets a what? A negative answer. So automatically, 2 minus 3 gives us minus 1. So what do we have? 2s raised to the power minus 1. Then y raised to the power 4. Remember, you are not allowed to leave a negative answer up. So what do? You bring it down. Now I told you I think in example 1 or so, yes, that when a negative power at the numerator comes down, it becomes a positive power. So if this comes down, what will be left on top? It becomes 2y raised to the power 4. And then what comes down? X. Simple as that. So this becomes the answer to that question. There's no need to put 1 here because x raised to the power 1 will still give us what? X. But if the number here was 2, what will be down? X raised to the power 2. If the number here was 3, what will be here? X raised to the power 3. But because it is 1, there's no need. You understand? Because x raised to the power 1 is the thing back. So now, the answer becomes 2y raised to the power 4 over x. Okay, that is question number 3. Now let us go to question number 4. Question number 4. Now, you will notice that question number 4 is like question number 2, but something is happening. The power is carrying a negative sign. And remember, in our last class, when we treated laws of indices, I gave you a law that is called negative fractional power law. We said something like that. Yeah, let me where we said if you have s raised to the power minus m over n. And then I told you that the first thing we are going to do is to eliminate this minus sign. And how do you eliminate the minus sign? I told you by reciprocating the base, by turning the base upside down. So if I turn x upside down, it becomes 1 over x. And then what becomes here now? A positive power, m over n. There is no more minus sign. So let us apply this law now in solving question number 4. Question number 4 says 25 over 16 raised to the power of minus 1 over 2. So like I said, the first, your main objective first is to eliminate this minus sign. And how do you do that? By reciprocating the base. So when I reciprocate 25 over 16, it becomes 16 over 25. You turn it upside down. Now, because I have reciprocated, the minus is out. So what is left there now? 1 over 2, positive. Positive, no more minus sign. Okay, now, like I always say, the denominator becomes the root of the base. And what's my denominator here? 2. So it becomes the square root of 16 over 25 raised to the power of, what is the numerator here? 1. What is it? Now, square root of 16 is 4. Square root of 25 is 5. All raised to the power of 1. And you know what that means? Actually, anything raised to the power 1 is the thing. So 4 over 5 raised to the power 1 will still give us 4 over 5. That becomes the answer to that question. That becomes the answer to that question. Okay, that is question number 4. Now let's go to question number 5. Question number 5. Question number 5. Alright, question number 5 says 3a raised to the power 4 times 10a all raised to the power of 3 over 5a raised to the power 2 all raised to the power of 3. Nearly like example number 3. Okay, how can we do this now? Like I said, this is 3a raised to the power 4 times, watch, the power outside affects everything inside. Are you there with me? So automatically, here becomes 10 raised to the power 3, then a raised to the power 3. The power affects each of them inside. So now, all over. Here becomes this 3 is also affecting 5, which is 5 raised to the power 3. And then remember, this my A now is carrying a power before 2. So the 2 will times 3. So here becomes 2 times 3. Now without wasting time, we have this 3A raised to the power 4 times 10 raised to the power 3A raised to the power 3. Let's go. Okay, all over 5 raised to the power 3, then A, 2 times 3 will give us 6, A raised to the power of 6. Okay, now you will notice that this is 3, this is 10 raised to the power 3, this is 5 raised to the power 3. None of the bases are the same, all the bases are different. So here becomes 3A raised to the power 4 times. Now what does 10 raised to the power 3 mean? 10 times 10 times 10. And that is 1000. So here becomes 1000 A raised to the power of 3 all over. Now 5 raised to the power 3 means 5 times 5 times 5. And I think that is 125. So here becomes 125A raised to the power of 6. Now, what do we do next? We pick out the numbers. This is 3, this is 1000, and this is 125. Are you with me? So if we do something like this now, 3 multiplied by 1000 will give us 3000. So I'll come here and I'll write 3000. Now I have A here, base A, and I have another A here, base A. And what sign is here? Times. Multiplication law, law 1. So what do? I pick one of the base A. Then what will my times change to? Plus. My multiplication law. So I add the powers together. 4 plus 3 over, what do I have here? 125 A raised to the power of 6. Now 4 plus 3 is 7. So here becomes 3000 A raised to the power of 7 over 125 A raised to the power of 6. Now without wasting time, this is a number here, 3000. This is another number here, 125. Now, how many times will 125 go into 3000? How many times will 125 go into 3000? I think that will give us, let us try to break it down without wasting time. Now imagine I have something like this, 3000 over 125. What can divide 3000 and 125? What can divide 3000 and 125? 5 can do it. Now let's go. How many times will 5 go into 3000? How many times will 5 go into 3000? That will give us 600. So here becomes 600 over. How many times will 5 go into 125? That will give us 25. This is our 25. Now, if we now say 600 over 25, something can still cancel 625. Now, 5 can still go. Now, how many times will 5 go into 600? Now, 5 will go into 600, okay, let's say 120 times. 120 times. So here becomes 120 over. How many times will 5 go into 25? 5. Now, what does that mean? Can 5 still cancel 120? Yes. So it means, how many times will 5 go into 120? That 5 into 12 is 2, remember 2, and 5 into 20 is 4. So what do we have? 24. So it means 125 will go into 3000 24 times. If you have a calculator, you can punch that and just write 3000 divided by 125, and you are going to get 24. But I just try to show you working. So now, we now have 24. Now, I have base A at the numerator. I have base A at the denominator. What do? Pick one of the base. Now, because I am dividing now, what will I do to the powers? I will minus. So here becomes what? 7 minus 6. And 7 minus 6 will give us what? 1. So here becomes 24A raised to the power of 1. And I said there is no need for 1. So remove your 1. I'll answer the question. 24a. That becomes the answer to that question. Question number 5. Okay, now without wasting time, let us go to question number 6. Question number 6 says, x raised to the power of 5 over 2 times root x. Yes, x raised to the power of 5 over 2 times root x. Now, naturally, some students don't really know what this root sign means. Okay, let me try to analyze something. If I have something like this, x raised to the power 1 over 2, fractional power, I told you the denominator becomes the root of the base. So automatically, it becomes the square root of x raised to the power 1. And square root of x raised to the power 1 is still the same thing as square root of x. Because I said x raised to the power 1 is the thing. Now, you will now notice that from this x raised to the power 2, we got square root of x. So it means, generally, watch me, root s is the same thing as x raised to the power 1 over 2. I want to bring out something out. Cube root of x is the same thing as x raised to the power 1 over 3. Fourth root of x is the same thing as x raised to the power 4. Therefore, the nth root of x becomes x raised to the power of 1 over n, where your n is a positive integer. It can take any number that is positive. So you see now that if you follow this pattern, you will get this. Anywhere I see root s, what will I put there now? X raised to the power of 1 over 2. So automatically here becomes x raised to the power 5 over 2 times x raised to the power 1 over 2. Now, the base is x, the base is x. They are the same. And we are timesing. And I said when you times, multiplication becomes addition. So automatically, I pick one of the base, x. Now my first power is 5 over 2. Now times becomes plus. What's the next power? 1 over 2. Now, it becomes x is equal to, x, which is the base. Now you will notice that my denominator is 2, my denominator is 2. And what sign is separated them? A plus sign. So what do? We look for the LCM. The LCM of 2 and 2 is 2. So my LCM is 2. Now, how many times will 2 go into 2? 1 times. Then 1 times 5, which is the numerator, will give us 5. Plus 2 into 2, 1. 1 times 1 will give us 1. So what do we have? X raised to the power of 5 plus 1 is 6 over 2. And now 6 divided by 2 will give us 3. So our final answer becomes x raised to the power of 3. I explain again. The root becomes half. The base are the same. Take one of the base, then add your powers. When you do 5 over 2 plus 1 over 2, we are going to get 6 over 2. And 6 divided by 2 will give us 3. And that becomes the final answer. So question number 6. Okay, now going forward to question number 7. Going forward to question number 7. Now question number 7 says 2 raised to the power of minus 5 minus 8 raised to the power of minus 2. Oh, now there's no law of indices here because law of indices is multiplication and division. But now we are subtracting. So what do? We just go. This alone is a negative power law in indices. And I said this minus becomes 1 over. Then your 2 raised to the power positive 5 comes down. Minus. This also, the minus becomes 1 over. Then your positive, your 8 raised to the power positive 2 also comes down. Now, what is 2 raised to the power 5? 2 times 2 times 2 times 2 times 2 into 5 places. Now it becomes 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is, what's it called? 16, 16 times 2 is 32, so we have 32. Minus, now, 8 raised to the power 2 means 8 times 8 into 2 places, and that will give us 64. Here becomes 1 over 64. Now what do? Because we have a minus sign separating these two fractions, we look for the LCM. Now, how do you look for LCM of numbers? Let's do it here. When you look for the LCM, you don't use the numerator, you use the denominators, meaning the number below. Now, let's look for the LCM now. This is 32, and this is 64. Now, LCM is lowest common multiples. So the first smallest number that can go into any of them, the number must not go into both of them, any of them. Now, I believe the first number is 2. Now, how many times will 2 go into 32? I believe that will give us 16. Now, 2 into 64. 2 into 64 will give us 32. Okay? Now, 2 can still go. 2 into 16 gives us 8. 2 into 32 gives us 16. 2 can still go. 2 into 8 gives us 4. 2 into 16 gives us 8. 2 can still go. 2 into 4, 2. 2 into 8, 4. 2 can still go. 2 into 2, 1. 2 into 4, 2. And 2 can still go. 2 here, 1. 2 here, 1. Now we have gotten 1, 1. Now let's calculate. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. So our LCM is 64. Now I come here, I rule my line, and I put my LCM 64. Now let's go. How many times will 32 go into 64? 2 times. Now 2 times 1 gives us 2 minus. How many times will 64 go into 64? 1. 1 times 1 will give us 1. So what do we have? 2 minus 1 becomes 1 over 64. That is the answer to question number 7. And lastly for today, before we say goodbye, we have question number 8. Question number 8 says 36 raised to the power of 1 over 2 plus 16 raised to the power of 1 over 4 all raised to the power of minus 2 over 3. Now what do we do here? This alone, fractional power law. This alone, fractional power law. So what does that mean? The denominator becomes the root of your base. The denominator becomes the root of your base. Let's go there. Here becomes the square root of 36 raised to the power of 1. Come in, please. The square root of 36 raised to the power of 1 plus. Now this becomes the fourth root of 16 raised to the power of 1 also. All raised to the power of minus 2 over 3. Now what do we do? Square root of 36 is 6. 6 raised to the power 1 is 6. So here becomes 6 plus 4 root of 16 means a number you will times 4 times to get 16. And we did it before. It was 2. Now 2 raised to the power 1 will still give us 2. Close the bracket. So what do we now have? We now raised to the power of what? Minus 2 over 3. Now 6 plus 2 is 8. 6 plus 2 is 8. So here becomes 8 raised to the power of minus 2 over 3. Now you see we are back again. We are back again to a negative fractional power law. And I told you, the first thing you do is to remove this minus sign. And how do you remove the minus sign? By reciprocating the base. So when I reciprocate 8, what do I have? 1 over 8. So here becomes 1 over 8. What becomes the power now? 2 over 3. No more minus sign. Now we come again. The denominator becomes the root of the whole base. So here becomes the cube root of 1 over 8 raised to the power. What's my numerator now? Raised to the power of 2. Now we all know what to do. This cube root is affecting 1 and is affecting 8. So what is the cube root of 1? Meaning, what will you multiply 3 times to get 1? It is 1. 1 times 1, 1. 1 times 1, 1. 1 times anything is 1. 1 times 1, 1, 1, 1 is 1. So automatically, what do we have? Here becomes 1 over cube root of 8 means the number you times 3 times to get 8, and that is 2 over 2 raised to the power of 2. And we know what this means. This 2 is affecting 1 as a power, and it's also affecting 2 as a power. So what do we have as our final answer? 1 raised to the power 2 means 1 times 1, and that is 1. 2 raised to the power 2 means 2 times 2, and that is 4. And the answer becomes 1 over 4. So we have been able to look at how you can solve some problems under simplification of what? Indices. In our next class, we shall be looking at how indices is related to equations. Till we meet again in our next class, don't forget to subscribe, like, share, and comment. And after you do all this, make sure you put on your notification button so that you get any video that I upload. Till we meet again, my name remains Jeff Manu. God bless you.